Hi dear children, last video we did some questions from exercise 7.1. Today I am going to continue that exercise 7.1. Seventh question. Find the point on the x-axis which is equidistant from ordered pair 2, -5 and ordered pair -2, 9. That means we need to find one point on x-axis. Suppose this is our x-axis. We need to find one point on this x-axis such that this point is equidistant from first point 2, -5, the second point -2, 9. Okay, I would like to call the first point as A, the second point as B. So we need to find P such that the distance from A to P is equal to the distance from B to P. Okay, the distance from A to P is equal to the distance from B to P. Since this point lies on x-axis, the y-coordinate of this point is equal to 0. Therefore, the coordinate of this point will be in the form ordered pair x, 0. Since this point lies on x-axis, the y-coordinate of this point is equal to 0. We are taking a general point. That's why the coordinate of that point is ordered pair x, 0. Now we are going to apply distance formula. We know that the distance formula D is equal to square root of x2 minus x1 all square plus y2 minus y1 all square. We have one square root of this distance formula. We need to eliminate that square root. If we want to eliminate square root, what we will do? If we want to eliminate square root, we need to take square on both sides. So I'm going to take square on both sides. AP square is equal to BP square. We need to eliminate the square root. That's why we are taking square on both sides. Now, the x coordinate of P minus x coordinate of A all square plus y coordinate of P minus y coordinate of A all square is equal to x coordinate of P minus x coordinate of B all square plus y coordinate of P minus y coordinate of B all square. That is x minus 2 all square plus this minus minus become plus and 5 square is 25. Minus minus become plus. So x plus 2 all square plus minus 9 square, that is 81. Now take that x plus 2 all square into LHS and 25 into RHS. That is x minus 2 all square plus minus x plus 2 all square is equal to 81 minus 25. Now that x minus 2 all square and x plus 2 all square, open it by using the identities a minus b all square and a plus b all square. Then this is become x square minus 4x plus 4 minus of x square plus 4x plus 4 is equal to 56. Now open this bracket, that is x square minus 4x plus 4 minus x square minus 4x minus 4 equal to 56. Minus 4 plus 4 get cancelled. Minus x square get cancelled. Then in LHS we will have minus 4x is equal to 56. That is minus 8x is equal to 56. So x is equal to minus 7. X is equal to minus 7. That is P of x, 0 we have. That is P of minus 7, 0 is our required point. P of minus 7, 0 is our required point. Now we are going to do the 8th question. Find the values of y for which the distance between the points P of ordered pair 2, -3 and Q of 10, y is 10 units. That means the distance between the points is given. We need to find out the missing coordinate. P of 2 comma minus 3 and Q of 10 comma y. This is our given point. The distance between these 2 points that is given, that is PQ equal to 10 units. Now again we are going to apply this distance formula. We have square root. We need to exclude that square root. For that I am going to take square on both sides. So PQ square is equal to 10 square. Now PQ square is x coordinate of Q minus x coordinate of P all square plus y coordinate of Q minus y coordinate of P all square is equal to 100. 10 minus 2, 8. 8 square is 64 plus minus minus become plus. So y plus 3 all square is equal to 100. That is 64 plus, open this y plus 3 all square by using a plus b all square. That is y square plus 6y plus 27 is 9 is equal to 100. That is y square plus 6y minus 27 is equal to 0. Now we are going to apply splitting the middle term method. We have y square plus 6y minus 27 is equal to 0. That is y square plus 6y, I am going to write it as 9y minus 3y minus 27 is equal to 0. Y square plus 9y minus 3y, that is our 6y minus 27 is equal to 0. From this first two terms, I am going to take y outside, that is y into y plus 9 we will get. In the second, these two terms, I am going to take minus 3 outside. So if we took minus 3 from this term, y will remain there, and here it is 9 equal to 0. Now consider these two terms. We know that y plus 9 is common. Y plus 9 is common. Take it outside. Y plus 9 into y minus 3 we will get. If you took that y plus 9 outside from the first term, we will have y there. And from the second term, minus 3 will be there. So y plus 9 into y minus 3 is equal to 0. Y plus 9 into product of two numbers is equal to 0 means either the first number is equal to 0 or the second number is equal to 0. So y plus 9 is equal to 0 or y minus 3 equal to 0. This implies y is equal to minus 9 or y is equal to 3. Y is equal to minus 9 or y is equal to 3. So this is our required y. Now we are going to do the ninth question. Ninth question. If Q of 0, 1 is equidistant from P of 5, minus 3 and R of x, 6, find the values of x. Also find the distances QR and PR. Okay, so we need to find out the value of x. Q of 0, 1, which is equidistant from P of 5, minus 3 and R of x, 6. It is given in the question. Q is equidistant from P and R. If Q is equidistant from P and R, we will have QP is equal to QR, right? Q is equidistant from P and R means QP equal to QR. We will take square on both sides. So QP square is equal to QR square. Now, x coordinate of P minus x coordinate of q all square plus y coordinate of p minus y coordinate of q all square is equal to x coordinate of r minus x coordinate of q all square plus y coordinate of r minus y coordinate of q all square. This we will get. This is 25 plus minus 3 minus 1 is minus 4, minus 4 square is 16 is equal to x minus 0 is x. So we will have x square. 6 minus 1 is 5. 5 square is 25. 25 get cancelled. So x square equal to 16. That means x is equal to plus or minus 4. Here we have two values for x, that is plus or minus 4. We need to find out the distances QR and PR. For that, first I am going to consider x is equal to plus 4. First I am going to consider x is equal to plus 4. If x is equal to 4, then QR is equal to here. This r of x comma 6 become r of 4 comma 6 because we took the value of x as 4. Now QR is equal to square root of x coordinate of r minus x coordinate of q all square plus y coordinate of r minus y coordinate of q all square. And this is equal to square root of 4 square plus 5 square is equal to square root 41. Now PR is equal to x coordinate of r minus x coordinate of p all square plus y coordinate of r minus y coordinate of p. 1 plus 81 is equal to square root 82. Square root of 1 plus 81 is equal to square root 82. So if x is equal to 4, we got the value of QR as square root 41 and PR is equal to square root 82. If x is equal to minus 4, then this r of x comma 6 become r of minus 4 comma 6. Now PR is equal to square root of x coordinate of r minus x coordinate of p all square plus y coordinate of r minus y coordinate of p all square. That is equal to square root of minus 4 minus 5 minus 9 square is 81 plus 6 minus 3 become 9. 9 square is 81. That is equal to 9 root 2. Now QR is equal to square root of x coordinate of r minus x coordinate of q all square plus y coordinate of r minus y coordinate of q all square. That is equal to square root of minus 4 square is 16 plus 6 minus 1 is 5. 5 square is 25 is equal to square root 41. 10th question. Find a relation between x and y such that the point ordered pair x comma y is equidistant from the points ordered pair 3 comma 6 and ordered pair minus 3 comma 4. We need to find the relation between x and y such that the ordered pair x comma y is equidistant from the given points. X comma y is equidistant from the given points ordered pair 3 comma 6 and the ordered pair minus 3 comma 4. Okay, let it be P. This one is A and this one is B. So P is equidistant from A and B. That means the distance from A to P is equal to the distance from B to P. That is AP is equal to BP. Now take square on both sides. AP square is equal to BP square. X coordinate of P minus X coordinate of A all square plus Y coordinate of P minus Y coordinate of A all square is equal to X coordinate of P minus X coordinate of B all square plus Y coordinate of P minus Y coordinate of B all square. That is X minus 3 all square plus Y minus 6 all square is equal to X minus 3 all square plus Y minus 4 all square. Clear? Now just open all the brackets by using that identities A plus B all square and A minus B all square. We will get it as X square minus 6X plus 9 plus Y square minus 12Y plus 36 is equal to X square plus 6X plus 9 plus Y square minus 8Y plus 16. That is become minus 12x minus 4y plus 20 is equal to 0. That is, divide this equation throughout by 4, minus 4, then we will get 3x plus y minus 5 is equal to 0. Divide this expression with minus 4, then we will get 3x plus y minus 5 is equal to 0. This is our required relation between x and y